We're going to be applying patterns and functions in this video. We're at 20D. And of course, if you've missed or skipped any of the previous videos, they're linked in this description, along with some other helpful ones. In math, a pattern is an ordered set of numbers or terms. A pattern can also be an ordered set of objects, but in math, it's numbers and terms. And their order helps us to determine what comes next. And the pattern will follow a rule. If we can figure out the rule, we'll be able to find the missing parts of the pattern. So if you look at these numbers here, you can compare the first number, 1, to the second number, 2, and figure out what the difference is, and then compare 2 to 4, figure out the difference, 4 to 8, and we can see what's happening is it's going times 2. So we know the next number in the pattern would be 16 times 2, or 32. We just figured out the rule. For this one, we compare 1 to 5, it went up by 4, then it went up by 4 again, then it went up by 4 again, so we know the next number would be going up by 4. 17 plus 4 is 21. This one's a little different. It's going plus 8 minus 5, plus 8 minus 5. So we know the next number would be 19 because the pattern tells us that we would be adding 8. See? In algebra, functions follow pattern rules. A function is the relationship between two quantities in which one quantity, y, uniquely depends on the other, x. For each input value of x, there's one output value of y. And this is what it means. If we have x as a 2, that's our input, and we put it into this function, this equation, 5 times 2, our output's going to be a 10. But if we change the value of x to be a 3 and put it into that function, that equation, our output will be 15. So see how it uniquely affects the function? Depending on what the input is, we get a unique output. A function table matches an input value x with an output value y. Here's our function, y equals 5x. It doesn't matter if the y equals is in the front or the back. It's the same thing. We can fill this table with amounts that will make this true. 5 times a negative 2 is going to give us a negative 10. 5 times a negative 1 will give us a negative 5. 5 times 0 will give us 0. See? As this column is going up by 1, this column is going up by 5. That's its rule. See? So what's happening is, here's our function, 4 plus x equals y. We just find values for x and y that will make this true. If x is a 0, 4 plus 0 is 4. See? If x is a 1, then 4 plus 1 is 5. That's the input. That's our output. And they're unique. We can even do y equals 3x plus 2 and find numbers that will make this equation true, this function true. If x is a negative 3, then y is going to be a negative 7. 3 times negative 3 is a negative 9 plus 2 brings us back up to a negative 7. See? If x is a 0, 3 times 0 is 0 plus 2 brings us to a positive 2. See? All the numbers on this table make that function true. And these are actually ordered pairs. We're going to talk about that coming up soon. How many blocks would be in the next stack? Well, there's 3 blocks here, 6 blocks here, 10 blocks here. We compare the difference between these two, then we compare the difference between these two to see if there's a rule. It's going plus 3, plus 4, so we can assume the next one would be plus 5. The next stack would have 15 blocks. We can complete the function table for 6x minus 4 equals y by putting in numbers that will make it true. It's giving us some of them, but look, it's missing some. So if x is a 5, that means we have 6 times 5 minus, that's a 30, minus 4 would be 26. So the missing y value would be 26 in this function table. See? 6 times something minus 4 equals 44. Well, 6 times 7 is 42. If we took 4 away, we'd only have 38, so that's not big enough. 6 times 8 is 48, and take away 4, that's 44, so the missing value for x would be an 8. See? And this one says for the function y equals x divided by 5, which of these values for x results in a fractional value for y? So here are our choices. If we do number 1, which is 10 divided by 5, that's going to give us a whole number 2. That's not a fraction. If we do number 2, which is 12, we get a 2 and 2/5. And if we compare all the other ones, they're giving us whole numbers. This is the only one that has a fraction in it, so the answer is number 2. Now we can also have a function table going horizontally. See that? Generally, it goes vertically like this, but it can be written like this. You're usually going to see it like this, though. This is 2x plus y equals 0. Which of these values for x and y make the equation true? So notice it says x and y. So it would be x, and that would be y. We can make a table and try to find numbers that will make this true. If we do 2 times -1, well, that's a -2. And if we add 2, that would give us a 0, right? Because that would make a 0 pair. -2 plus 2. 2 times 0 is 0. Plus 0 would be 0. So we could have 0, 0. But those aren't choices. This one and this one are not choices in the list. The choice that comes up is the +1 and the -2 as number 5. So we make a function table to see which pairs of numbers make the equation true, which answer choice matches a pair from this table, and we get number 5 as +1 and -2. 2 times 1 is 2, plus a -2 is 0. And that's the one that fits. Now be careful, because this one says for the equation x plus 4 times x minus 3 equals 0, there are 2 values of x that will make the equation true. So it's not saying x and y, it's saying 2 values of x. So if this x is this -4, then that means that has to be a -4. You can't have x equal one number in this part and equal another number in that part. X is x. If it's representing a number, it represents that number throughout the entire equation. So what it's saying is we can do 2 different sets of equations. We can do one where their x is both -4, and then we can try it again where both x's are a +3. See? And what are these values? Well, remember that any number multiplied by 0 is 0. So anytime we make something in these parentheses a 0, it doesn't matter what's in that one, because 0 times something is 0, isn't it? And vice versa. If something in here becomes a 0, then it doesn't matter what's in here, because something times 0 is always 0. And remember, parentheses next to each other means multiply. If x is a -4, then we do -4 plus 4. Well, that gives us a 0. -4 minus 3 gives us a -7. 0 times -7 is 0. So that one worked. -4 worked. If we use a +3, 3 plus 4 is 7. But +3 minus 3 gives us a 0 pair. That makes a 0. And 7 times 0 is 0. So the -4 and +3, number 1, fit. Those were 2 that made the equation true. Okay? So it's really important if they make the equation true. Now, you're going to come across this in algebra. You're going to see an f with a little x in parentheses. We read this as f of x. It means the number assigned to x by the function f. Now, this f of x really represents y. I know it's crazy, but it's true. And if you watch my Algebra 1 12.1a, b, and c videos, it'll explain this more. We read it as f of x. It means the function of x. So you can also read it as function of x, but most people say f of x, okay? So there's several names for x and y values depending on what's going on. It could be called, x could be called the domain, the input, the x-coordinate. It's also the first members in a relation. So we have ordered pairs of x and y, and I wish I had my green and orange, but this would be x and that would be y, so we would have -4 and maybe a 2, and that would be considered an ordered pair that would make an equation true, okay? So the ordered pair for here could be 20 for x and 4 for y. See, that makes an ordered pair That makes an ordered pair. I'm going to talk about this some more, but what I wanted to talk to you about is how they have different names. So this is the first set of members in this ordered pair relation, that x, and then y would be the second one. It could be called the range, the output, the y coordinate, the f of x, and that second member of the ordered pair, see? And I know it's confusing when they have a lot of different names, but even I have several names depending on the situation and depending on what's going on. Some people will refer to me as JoAnn. There's some people in this world that call me Mom. There's even some people that call me Grandma. And there's some people that call me worse names or hey you. So depending on what the situation is, I have different names. So it's understandable that other things can have different names, okay? So don't let it bother you. I have one last example for you. Bob earns time and a half overtime pay for any hours worked over 40 hours. He earns $16 per hour regular pay. How much will he earn for 46 hours of work? So we're going to let x equal his regular pay. That's $16. So time and a half would be x plus half of x. It would be the 16 plus half of 16, see? It would be 1.5x, but we're going to go with the x plus half x, all right? So to represent the 46 hours that he worked, for the first 40 hours he gets regular pay, so that's 40 times the 16, see? The overtime pay would be the extra 6 hours, wouldn't it? So we'd have 6 hours plus half of the 16. So what we would do is we would do 6x plus 6 times half x. We could also do 6 times 1.5x. And that would equal y, his paycheck. When we do 40 times 16, we get 640. When we do 6 times 16, we get 96. And when we do that half, we get 48. We add them all up and get 784. Now you can also just do 40 hours at $16 and figure time and a half would be 16 plus half of 16 is 8. 16 plus 8 is 24. So you could do 6 hours times 24. Whatever helps you solve this problem. You're going to get the same amount. And if we keep the same hours worked, he still works 46 hours, but now he got a raise. Maybe he's making $18 an hour. That's going to affect y, isn't it? It's going to affect the outcome, his paycheck. So this y is dependent on that x, isn't it? So you should now be ready to do the skill focus on page 241. And to truly understand functions, you should watch chapter 12 of my Algebra 1 playlist. And I'll have a link to that. This GED math book that we're using and this playlist expects you to learn all of high school algebra in just 5 little lessons, and that's almost impossible. So you're going to have to rely on my other videos, okay? The next one we're going to be doing is multiplying factors with 2 terms. That's lesson 21A. So we're going to a complete different lesson, and they expect you to be finished learning about functions, which I think is a little silly. I'm going to have a link to my Algebra Word Problems playlist, which will help you. You need to watch those too to become familiar with word problems because there's so many on this test. I'm going to have a link to my grade 6 video about functions. There's a couple videos from grade 8 about functions, and then there's all of that chapter 12. And you could go into Algebra 2 if this seems very easy for you. I would hope that you would understand the Algebra 1 part first because it starts getting a little more difficult, but that's going to help you. And I'm going to have the previous videos for this lesson 20 linked in the description. So all you have to do is click on them, okay? Sometimes I might just put the video into the playlist following the lesson because I'll feel it's so mandatory, all right? But I would hate to put all of chapter 12 into this playlist. I would hope that you would just click on it. So I really think you can do this. You're the only person who can make yourself better, all right? And you're the only person who cares about you as much as you can, all right? I believe in you. I think you can do this. Stick with it and stay strong, all right? I'll see you next video. Bye.